Zashad and I am from chemistry department. Today I am here to present the topic decomposition of the sodium thiosulfate by the mineral acids. So let's start with the contents, which includes aim, background, prediction, scientific reason for prediction, hypothesis, method, result, evolution, conclusion. Sodium thiosulfate. In its solid form, it is a crystalline solid which has a tendency to readily lose water. Sodium thiosulfate is readily soluble in water and it is also referred to as a sodium hyposulfate. It can be noted that the shape of the thiosulfate ion is tetrahedral and in a solid state of the sodium thiosulfate. The distance between the two sulfur atoms in the thiosulfate ion is comparable to the distance between the two sigma bonded sulfur atoms. This implies that the sulfur which is not bonded to any oxygen hold a negative charge. Aim: to investigate how the rate of reaction between the sodium thiosulfate and the hydrochloric acid is affected by changing the concentration. Background: the reaction when the sodium thiosulfate reacts with the hydrochloric acid, sulfur is produced. The sulfur form is a very small particle and casts the solution of the cloud over and turn a yellow color. This causes the cross to fade and eventually disappear. Sodium thiosulfate plus hydrochloric acid, sulfur, sodium chloride, sodium dioxide, water. Prediction: as the concentration of the sodium thiosulfate increases, the length of the time for the cross to disappear decreases inverse. This is because the increase of the concentration of the sodium thiosulfate will increase the rate of reaction between the hydrochloric acid and the sodium thiosulfate particles. Scientific reason for the prediction: the results for the preliminary experiment supports the prediction made. For the result, you can see that there is a directly proportional relationship between the concentration, then the rate of reaction will also increase. The experiment is testing how the rate of reaction is affected when the concentration is changed. The theory said that increasing the concentration can increase the rate of molecule conclusion. The phenomena behind all of this is the conclusion theory and how it plays a big role in the investigation. The higher the concentration, or the less time faster it will take for the time to return into the equilibrium. And if the concentration is decreased, time taken for the solution to go cloudy increase. Hypothesis: the higher the concentration, the faster the rate of reaction will be and the time taken to reach equilibrium will decrease. A more dilute concentration will have a long rate of reaction and the longer time to reach equilibrium. Method: gather all the apparatus needed for the experiment. Using a weight balance, we measure out 8 grams of the sodium thiosulfate that we add to the 200 centimeter cube of the water. We mix the solution until all the crystals were dissolved. When you pour 50 centimeter cube, 40 centimeter cube, 30 centimeter cube, 20 centimeter cube and the 10 centimeter cube of the solution into the 5 identical conical flash, then you add water to the other conical flash so that the total volume in each flash is a 50 centimeter cube. Make sure to label the flash so you know which one has much concentration. Once that's done, you must now take a break and add 35 centimeter cube of the concentrated hydrochloric acid to the 65 centimeter cube of the water to make a dilute solution. Now take a piece of the paper and draw a black cross on it and then place one of the flash on the paper. Do one flash at a time. Use a measuring cylinder, measure out 5 centimeter cube of the hydrochloric solution and add this to the flash immediately. Stir the flash and start the stopwatch. One person should do this part. As soon as you can't see the cross anymore, stop the stopwatch and record the result in the table. The rate of reaction is measured by dividing 1 by the time taken for the reaction to take place. The number of the moles of the sulfur used 8/32, 0.25 moles. You can see for the graph that concentration increase, the time taken for the solution to go cloudy decrease. So the stronger concentration, the faster the rate of reaction is. As the concentration of the sodium thiosulfate decrease, the time taken for the cross to disappear increase. This is an inverse relationship. When the equilibrium was reached, the solution then turns a yellow color. The stronger the concentration was, the higher the turbidity was. When the equilibrium was reached, as the two gases in the water were released, the more concentrated solution has the more molecules. which more collision will occur. So therefore, the rate of reaction should depend on how frequently the molecule collude. So the more molecule has a greater conclusion, and the reaction happen faster as the more products are made in the shorter time, or related to the conclusion theory. Evaluation. The method we used was fairly accurate. Our results were not affected, but they were good enough for us to see what happened during the experiment. So overall, the result proved the hypothesis, and I was able to draw the graph and a line of the best fit. In our experiment, we keep the HCl a constant, as also keeps the volume of the solution. Was important to get more accurate result. The results were fairly reliable under our condition. They could be a bit off from the bad measuring, unclean equipment, and the timing. Conclusion. When the concentration of the sodium thiosulfate was increased, the rate of reaction increased, and the time taken to reach the equilibrium decreased. So therefore, the rate of reaction is directly proportional to the concentration. Thank you for your attention.